Recall that thanks to the central limit theorem, yay, with sufficiently large samples, the t-distribution starts to look like the z-distribution, so the difference between a z-score and a t-score is only noticeable on samples less than 30. Much of what you learned about z-tests applies to t-tests. Even the formulas to calculate this should look very much the same. Just like with z-tests, you start by stating your hypotheses. Let's imagine you are conducting a study about the average number of miles hiked by hikers in the Pacific Northwest in a given year. The mean is 500 miles, but you think it actually might be higher. So your null and alternate hypotheses would be for an upper one-tailed hypothesis test. Next, you select your alpha or level of significance. In this case, you select 0.05. What is the critical value that you'll need to reject the null hypothesis? To do this, the population mean proposed in the null hypothesis is added to the product of the critical t-score at the alpha level given the degrees of freedom and the standard error. In this version of the study, you sample 16 people, so your degrees of freedom is 15, n-1. When alpha equals 0.05, t with 15 degrees of freedom is 1.753. If we know the sample standard deviation is 52.63, and we have sampled 16 hikers, we find that the critical value is 523.07. If our sample results in an average that is greater than 523.07, we reject the null hypothesis. This is much larger than the 507.07 we calculated with the z-score, and that is entirely a function of the sample size in this example, because I used the same standard deviation in both the t-test and z-test examples. Increasing the sample standard deviation, which is more likely in a small sample when compared to the population, you would see this value increase even more. More commonly, you calculate the t-score by subtracting the population mean from the sample mean and dividing by the standard error. Imagine that we obtained an average of 525.01. Using the critical value that we just calculated, we know that this will be significant. However, let's play this out just to see how it works using this formula. Here, you want the resulting value to be larger than the critical t-score of 1.753. The difference between the population and sample mean is 25.01, which divided by the standard error results in 1.90, which is greater than the critical t value of 1.753, so we reject the null hypothesis.